Section 3.6 Applications. In this video, we will see how to solve advanced applications with requirements for word problem solutions, consecutive integers, consecutive odd integers, consecutive even integers, and tables. Because we've increased our fundamental ability to simplify algebraic expressions, we are now able to tackle a number of more advanced applications. Before we begin, we remind readers of required steps that must accompany solutions of applications. Requirements for word problem solutions. 1. Set up a variable dictionary. You must let your readers know what each variable in your problem represents. This can be accomplished in a number of ways. Statements such as, let P represent the perimeter of the rectangle, or labeling unknown values with variables in a table, or labeling unknown quantities in a sketch or diagram. 2. Set up an equation. Every solution to a word problem must include a carefully crafted equation that accurately describes the constraints in the problem statement. 3. Solve the equation. You must always solve the equation set up in the previous step. 4. Answer the question. This step is easily overlooked. For example, the problem might ask for Jane's age, but your equation solution gives the age of Jane's sister, Liz. Make sure you answer the original question asked in the problem. 5. Look back. It's important to note that this step does not imply that you should simply check your solution in your equation. After all, it's possible that your equation incorrectly models the problem situation, so you could have a valid solution to an incorrect equation. The important question is, does your answer make sense based on the words in the original problem statement? Consecutive integers. The integers are consecutive in the sense that one follows right after another. For example, 5 and 6 are a pair of consecutive integers. The important relation to notice is the fact that the second integer of this pair is 1 larger than its predecessor. That is, 6 equals 5 plus 1. Consecutive integers. Let k represent an integer. The next consecutive integer is the integer k plus 1. Thus, if k is an integer, then k plus 1 is the next integer, k plus 2 is the next integer, after that, and so on. Example 1. The three sides of a triangle are consecutive integers, and the perimeter is 72 inches. Find the measure of each side of the triangle. Solution. We follow the requirements for word problem solutions. Set up a variable dictionary. In this case, a carefully labeled diagram is the best way to indicate what the unknown variable represents. So, we draw a right triangle. We label three sides of the triangle with expressions representing the consecutive integers, k, k plus 1, and k plus 2. 2. Set up an equation. To find the perimeter p of the triangle, the sum of the three sides would be p equals k plus k plus 1 plus k plus 2. However, we're given the fact that the perimeter is 72 inches, thus 72 equals k plus 1 plus k plus 2. Solving the equation on the right, we regroup and combine like terms to get 72 equals 3k plus 3. Now we can solve this equation. First, we'll subtract 3 from both sides to get 72 minus 3 on the left-hand side equals 69, and on the right-hand side, 3k plus 3 minus 3 equals 3k. Then, we'll divide both sides by 3 to isolate k. On the left, 69 divided by 3 is 23, and on the right, 3k divided by 3 is k. So k equals 23. 4. Answer the question. We've only found one side, but the question asks for the measure of all three sides. However, the remaining two sides can be found by substituting 23 for k into the expressions k plus 1 and k plus 2. And k plus 1 equals 23 plus 1 equals 24, and k plus 2 equals 23 plus 2 equals 25. Hence, the three sides measure 23 inches, 24 inches, and 25 inches. 5. Look back. Does our solution make sense? Well, the three sides are certainly consecutive integers, and their sum is 23 inches plus 24 inches plus 25 inches equals 72 inches, which was the given perimeter. Therefore, our solution is correct. Consecutive odd integers. The integer pair 19 and 21 are an example of a pair of consecutive odd integers. The important relation to notice is the fact that the second integer of this pair is 2 larger than its predecessor. That is, 21 equals 19 plus 2. Consecutive odd integers. Let k represent an odd integer. The next consecutive odd integer is k plus 2. Thus, if k is an odd integer, then k plus 2 is the next odd integer. K plus 4 is the next odd integer after that, and so on. Example 2. The length and width of a rectangle are consecutive odd integers, and the perimeter is 168 centimeters. Find the length and width of the rectangle. Solution. We follow the requirements for word problem solutions. 1. Set up a variable dictionary. In this case, a carefully labeled diagram is the best way to indicate what the unknown variable represents. In our schematic diagram, if the width k is an odd integer, then the length k plus 2 is the next consecutive odd integer. The rectangle has sides k, k, k plus 2, and k plus 2. So, setting up an equation to find the perimeter of the rectangle, the sum of the four sides, the perimeter p equals k plus the sum of k and 2 plus k plus the sum of k and 2. However, we are given the fact that the perimeter is 168 centimeters. Thus, 168 equals k plus k plus 2 plus k plus k plus 2. 3. Solving the equation on the right, we'll regroup and combine like terms to get 168 equals 4k plus 4. Now, solving, we'll subtract 4 from both sides. On the left, 168 minus 4 is 164, and on the right, 4k plus 4 minus 4 is 4k. Then we'll divide both sides by 4 to isolate k. On the left, 164 divided by 4 is 41, and on the right, 4k divided by 4 is k. So k equals 41. Answering the question, we've only found the width, but the question asks for the measure of both the width and the length. However, the length can be found by substituting 41 for k into the expression k plus 2, since length was k plus 2. So k plus 2 equals 41 plus 2 equals 43. Hence, the width is 41 centimeters and the length is 43 centimeters. 5. Look back. Does our solution make sense? Well, the width is 41 centimeters and the length is 43 centimeters. Certainly consecutive odd integers. Further, the perimeter would be 41 centimeters plus 43 centimeters plus 41 centimeters plus 43 centimeters equals 168 centimeters. So our solution is correct. Tables. In the remaining applications in this section, we will strive to show how tables can be used to summarize information, define variables, and construct equations to help solve the application. Example 3. Hugh inherits $10,000 and decides to invest in 2 different types of accounts. A savings account paying 2% interest and a certificate deposit paying 4% interest. He decides to invest $1,000 more in the certificate of deposit than in savings. Find the amount invested in each account. Solution. We follow the requirements for word problem solutions. 1. Set up a variable dictionary. We're going to use a table to summarize information and declare variables. In the table that follows, we let S represent the amount Hugh invests in the savings account. Using a variable letter that sounds like the quantity it represents is an excellent strategy. Thus, in this case, letting S represent the amount invested in savings is far better than letting X represent the amount invested in savings. So, because S represents the investment in savings, and we are told that the investment in the certificate of deposit, the CD, is $1,000 more than the investment in savings, the investment in the CD, or certificate of deposit, is therefore S plus 1,000, as indicated in the table. 2. Set up an equation. The second column of the table reveals that the sum of the individual investments in the CD and savings totals $10,000. Hence, the equation that models this application is S plus 1,000, the investment in the certificate of deposit, plus S, the investment in the savings account, equals 10,000, the total invested. 3. Solve the equation. On the left, regroup and combine like terms. S plus 1,000 plus S is equivalent to 2S plus 1,000. So now we'll solve the equation by subtracting 1,000 from both sides. We get, on the left-hand side, 2S plus 1,000 minus 1,000 equals 2S. And on the right-hand side, 10,000 minus 1,000 equals 9,000. Now we'll divide both sides by 2 to isolate S. On the left-hand side, 2S divided by 2 is S, and on the right-hand side, 9,000 divided by 2 is 4,500. 4. Answer the question. We've only found the investment in savings, but the question also asks for the amount invested in the CD. However, the investment in the CD is easily found by substituting 4,500 for S in the expression S plus 1,000. So S plus 1,000 equals 4,500 plus 1,000 equals 5,500. Hence the investment in savings is 4,500. And the investment in the CD is 5,500 or 5,500. Looking back, does our solution make sense? Well, the amount invested in the CD is 5,500, which is certainly 1,000 more than the 4,500 invested in savings. Secondly, the two investments total 5,500 plus 4,500 equals $10,000. So our solution is correct. Example 4. Jose cracks open his piggy bank and finds that he has $325, all in nickels and dimes. He has 10 more dimes and nickels. How many dimes and nickels does Jose have? Solution. We follow the requirements for word problem solutions. 1. Set up a variable dictionary. We're going to use a table to summarize information and declare variables. In the table that follows, we let N represent the number of nickels from the piggy bank. Using a variable letter that sounds like the quantity it represents is an excellent strategy. Thus, in this case, letting N represent the number of nickels is far better than letting X represent the number of nickels. Because there are 10 more dimes and nickels, the number of dimes is N plus 10, recorded in the second column. In the third column, N nickels worth 5 cents apiece have a value of 5 N cents. Next, N plus 10 dimes worth 10 cents apiece have a value of 10 times N plus 10 cents. The final entry in the column gives the total value of the coins at 325 cents. 2. Set up an equation. The third column of the table reveals that the sum of the coin values is 325 cents. Hence, the equation that models this application is 5n plus 10 times n plus 10 equals 325, which sums the value of the nickels and the value of the dimes to a total of 325 cents. 3. Solve the equation. On the left, we use the distributive property to remove parentheses. 10 times the sum of n plus 10 is the same as 10 times n plus 100. Then combine like terms. 5n plus 10n on the left is 15n, so we get 15n plus 100 equals 325. Now we'll solve, subtracting 100 from both sides. On the left-hand side, we have 15n plus 100 minus 100 is 15n, and on the right-hand side, 325 minus 100 is 225. Now we'll divide both sides by 15. On the left, 15n divided by 15 is n, and on the right, 225 divided by 15 is 15. 4. Answer the question. We've only found the number of nickels, but the question also asks for the number of dimes. However, the number of dimes is easily found by substituting 15 for n in the expression n plus 10. n plus 10 equals 15 plus 10 equals 25. Hence, Jose has 15 nickels and 25 dimes. 5. Looking back, does our solution make sense? Well, the number of dimes is 25, which is certainly 10 more than 15 nickels. Also, the monetary value of 15 nickels is 75 cents, and the monetary value of 25 dimes is 250 cents, a total of 325 cents, or $3.25. So our solution is correct. Example 5. A large children's organization purchases tickets to the circus. The organization has a strict rule that every 5 children must be accompanied by one adult guardian. Hence, the organization orders 5 times as many child tickets as it does adult tickets. Child tickets are $3 and adult tickets are $6. If the total cost of tickets is $4,200, how many child and adult tickets were purchased? Solution. We follow the requirements for word problem solutions. 1. Set up a variable dictionary. We're going to use a table to summarize information and declare variables. In the table that follows, we let A represent the number of adult tickets purchased. Using a variable letter that sounds like the quantity it represents is an excellent strategy. Thus, in this case, letting A represent the number of adult tickets is far better than letting X represent the number of adult tickets. Because there are 5 times as many children's tickets purchased than adult tickets, the number of children's tickets purchased is 5A, recorded in the second column. In the third column, 5A children's tickets at $3 apiece will cost 3 times $5A dollars, and A adult tickets at $6 apiece will cost $6A dollars. The final entry in the column gives the total cost of all tickets as $4,200. 2. Set up an equation. The third column of the table reveals that the sum of the cost for both children and adult tickets is $4,200. Hence, the equation that models this application is 6A plus 3 times 5A equals $4,200, which sums the cost of children and adult tickets is $4,200. 3. Solve the equation. On the left, use the associative property to remove parentheses. So 3 times 5A is 15A. Then combine like terms. 6A plus 15A equals 21A. Now solve. Divide both sides by 21. On the left-hand side, 21A divided by 21 equals A, and on the right-hand side, 4,200 divided by 21 is 200. 4. Answer the question. We've only found the number of adult tickets, but the question also asks for the number of children's tickets. However, the number of children's tickets is easily found by substituting 200 for A in the expression 5A. So 5A equals 5 times 200 equals 1,000. Hence, 1,000 children's tickets and 200 adult tickets were purchased. 5. Look back. Does our solution make sense? Well, the number of children's tickets purchased is 1,000, which is certainly 5 times more than the 200 adult tickets purchased. Also, the monetary value of 1,000 children's tickets at $3 apiece is $3,000, and the monetary value of 200 adult tickets at $6 apiece is $1,200, a total cost of $4,200. Our solution is correct.